Welcome to the Echoluma demonstration room. Echoluma is a beat-driven lighting system designed for Unreal Engine, allowing you to create synchronized movement, light patterns, and effects using tempo. This walkthrough highlights the core features that power rhythmic lighting behaviors inside your scenes. Everything in Echoluma is driven by tempo. BPM value defines the rhythmic foundation that drives patterns, movement timing, and effects across the system. While BPM defines the timing of a beat, the envelope defines how that beat behaves. Both lights share the same BPM, but use different envelope settings, demonstrating how these parameters shape the character of each beat. Beat patterns introduce selective activation. Each pattern index represents a beat, and the light only activates when that index is enabled. In this example, the first light uses mono behavior and activates on every beat, while the second light follows a pattern that selectively activates certain beats. Sequences expand patterns into multi-step lighting behaviors, where each step can store its own values. This allows lights to change their behavior over time and still remain synchronized to the same BPM. Offsets allow lights to execute beats at different moments while remaining synchronized to the same BPM. This creates staggered lighting patterns across multiple fixtures, producing wave-like or cascading effects without changing the underlying beat structure. Hit and dim values define how a light appears during activation and while idle. In this example, the first light uses dim values, maintaining a standby look between beats before transitioning into its hit state. The second light has no dim values applied, remaining off until a beat activates it. Auto-color behavior introduces dynamic color variation synchronized to the beat. In group mode, a new color is randomly assigned on each beat, but the entire group of lights shares the same color. In individual mode, each light receives its own randomly assigned color on every beat. Automatic color assignments control how Echoluma applies dynamic color changes. The assignment setting determines whether automatic colors are applied to the hit state, the dim state, both, or not used at all. Offsets can also be controlled within sequences. Each step in a sequence can define its own offset value, allowing lights to shift. Movement presets provide fast, ready-made motion patterns for your lights. With just a few clicks, complex lighting movement can be added without manual animation. Movement behavior gives control over how motion plays out. Continuous keeps the movement updating without a defined completion point. Move and hold completes the movement once and then maintains its final position. Looping repeats the movement from the start point. Default, offset, and randomize are basic movement presets that provide quick ways to position and vary lights using pan, tilt, and roll values. Additive, sine wave, and pendulum presets are all continuous motions that use pan, tilt, and roll values as magnitude. Merge, separate, and orbit are target-based presets that allow lights to move relative to a focus actor. Sequencer-driven movement allows custom animations to be created using keyframes, giving artists complete freedom to design their own motion behaviors. Targeted movements use a focus actor and target radius to determine how lights rotate themselves around a scene reference. Focus actor allows lights to orbit, merge, or separate relative to that target in the scene. Target radius controls the distance of that movement, allowing the spread of lights around the focus point to be adjusted. Movement timing is controlled using move-in beats and speed multiplier. Move-in determines the time for a movement cycle to complete. Speed multiplier then scales that motion. Movement offsets allow each light to begin its motion at different times. By shifting the movement timing across multiple lights, a single motion pattern can produce flowing, wave-like choreography. Movement can also be sequenced across multiple steps. Each step can use a different movement preset, allowing motion patterns to evolve over time. Each coordinate system demonstrates rotation around a different axis: pan on Z, tilt on Y, and roll on X. Regardless of how the fixture is oriented in the scene, the motion follows the light's own pivot axes. Forward correction lets the beam originate from a different axis, while rotations still follow the fixture's pivot axes. Fixture mesh orientation directly affects how parts rotate. If the base, yoke, and head are imported with incorrect axes, their movements break. The yoke may rotate into the base, or the head into the yoke. Proper axis alignment when importing the mesh ensures each part moves correctly. Fixture meshes may use different forward directions. Without correction, the beam may originate from the wrong axis. Forward correction realigns the beam direction so the fixture behaves as expected. With correct mesh orientation and forward correction, fixture rotations behave exactly as expected. The key element of light effects is texture masking, also known as gobos. These textures shape the beam and project patterned light. Strobe creates rapid flashes of light synchronized to tempo. This display shows a selection of mask presets included with the system. Each texture creates a different projected pattern, forming the basis for a wide range of lighting effects. Mask textures can be transformed to change how patterns appear within the beam. They can also be animated independently of fixture movement using speed. Offsets change the starting rotation of mask textures, creating variation between fixtures. Light effects sequences combine different looks across steps, allowing movement and effects to change over time. Echoluma gives you a complete system for building synchronized lighting inside Unreal Engine. Now it's your turn to light it up.